about basics of probability. Now in this video we are going to discuss about experimental probability and theoretical probability. So what is experimental probability? So probability calculated on the basis of past data and experience is called an experimental probability. So simple, I'm using the past data available and I'm predicting about the future using that past data, using the analysis of that past data. Like for example, here I have a record of a football team, and it has come to know to me that is they have uh, in 2 games they have scored between 0 to 9, 10 to 9 in 4 games, 20 to 29 in 5 games. So this is past data available to me, and question is on the basis of past. Now I want to predict the probability that the team will score 30 to 39 points in their next game. So how can I predict? So how much time they have did it? So they have did it 3 times in the past. You can see 3, 39, 30 to 39. So and out of 16 games. So what will be the probability of the next game that they will score 30 to 39 points? Simple. 3 by 16. Correct. They have done it 3 times. So my probability that they will again repeat the same thing is 3 by 16. That simple. Experimental probability. Okay. Now here I want to discuss about experimental probability versus theoretical probability. Theoretical probability is a true probability of any particular event. So to understand that, okay, I will take a simple example. Okay, so suppose I have a bag with 100 marbles. 50 of them are red and 50 are blue. Now I ask you a simple question, that is, what is the probability of getting a red ball? So you will tell me 50 by 100, obviously 1 by 2, right? But I again I will ask you a further question, that it means that if I take out 10 balls one by one, then as per your answer I will get 5 red and 5 blue, right? But it is not possible that I can get 8 red and 2 blue. Yes, it is absolutely possible that I can get 8 red, 2 blue, 6 red, 4 blue. Perfectly possible, right? Even though my theoretical probability, true probability, it is 1 upon 2, it is perfectly possible that my experimental probability can differ from my theoretical probability. So if suppose I have 100 balls, it is perfectly possible that I can get 80 red and 20 blue. Why not? You can also try it, right? So my experimental probability comes to know to me after picking 100 balls. I found that 80 are red and 20 are blue. So what does my true probability shows? So it just shows that as I do a large number of experiments, a large number of marbles, 10,000 marbles, 20,000 marbles, then my experimental probability starts to approach my theoretical probability, and that is my true probability of that event. So here if I have 10,000 marbles, then my experimental probability will start to approach my theoretical probability. So in that scenario, it may be closer to 55% of red and remaining 45% of blue. So the most important thing that we have to remember is that as I conduct huge number of trials, as I draw huge number of balls one by one, 10,000, 20,000, 1 lakh, my experimental probability starts to approach my theoretical probability. And you have also heard about law of large numbers. So it tells the same thing. As I do huge number of experiments, then it just starts to approach the true probability of that event. So here if I have 10,000 marbles, and if I draw one by one, then my experimental probability will go closer and closer to 1/2, 1 by 2. Even if after doing that many experiments it is not approaching to that, or after doing not a 10,000 but 1 lakh marbles, then think that I can think that there is some problem. There are reasons because of this which is not happening. Okay, then the reason may be that one ball is more denser than the other, one marble is more denser than the other. Okay, one marble is biased, or it may also happen that there is 60% chance of coming one marble and 40% of another marble, even though if after conducting a huge number of experiments this is happening. So to give you more uh, good feeling about this, I will show you a simulation. Okay, so you can see here I have visited a website and here I have simulation. Okay, you will understand now very betterly. So now here I am taking about tosses. Okay, coins, heads and tails. Now I am doing here 15 tosses. Okay, so let's see what is true probability. We know 50%, right? So let's toss it. Observe it very carefully. You can see when I'm doing 15 tosses, see where my probability is going actually. See heads probability and see tails probability. Are they 15%? Are they 50-50%? No, right? So my experimental probability can be different, but as I approach huge number of trials, let's do huge number of trials. Okay, toss. Let's do it. See, observe it very carefully now. 50%, 55%, 46%. Now you can see it's approaching. It's approaching the true probability. Let's do couple of more. Let's do. See, you can see. You can see that, right? So now it's very close to 50%. And even after doing 400, even after doing 415 trials, it is uh, even though then it is even though after doing this many trials, my tails probability is 48% and not completely 50%. So you can see. So this is a good logical proof, I will say, to understand this. So you can go to this website, okay, to access that simulation. Okay, now let's move on. I hope you understood about experimental probability and theoretical probability, right? So this is a diagram that uh, I have taken picture of six after 600 tiles. So you can see it's very now very close to the 50% probability. Okay, so that is my true probability, theoretical probability and experimental probability difference. Now further we have addition rule after it. Now addition rule, we also have a basic logic for it, and we will accept it uh, in spite of anything. Okay, means it is natural to us, I will say. So addition rule, what it tells us, probability of A union B is P of A plus P of B minus P of intersection B. So to understand it, let's take an example. So like probability of jack or heart. Okay, I want jack, probability of jack or heart. So how many heart cards are there? 13, and jack are 4. But in the jack we have also jack of heart, and in the heart I have also jack. So I have counted it 2 times, right? Then so to nullify that effect, I will minus 1. So 4 plus 13 minus 1 upon 52, and that's simple. 16 by 52, that's simple. So even if we not have known this rule, we would have done like this only, correct? 4 plus 13 minus 1 upon 52. So that is addition rule. So probability of A intersection B, subtracting it avoids double counting. Now let's move on, or we will stop up to this. Okay, in the next video we are going to cover about multiplication rule, dependent independent events. Okay, so stay tuned. Thank you very much.